In sockets and sockets programming, there are certain functions, some structures you need to understand so that you program it. First thing is byte ordering. There are functions you will see HTONS, HTONL, HTOHS, and NTOHL. Now, these are the byte orders. First byte order is network byte order. The other one is host byte order. Host is your machine, network is the networking parts. Now, there is a difference. You just understand like this: when you have two systems, these are hosts, they have different byte order. But when you are on network, the byte order may be different. So, you have to convert it by yourself in your programming. In network stack, that is TCP IP, it wants network byte order. It wants network byte order where high order byte of the number is stored in memory at the lowest address. The Motorola Intel, like that thing. So this host to network, as I said, host may be your computer. So host to network, in short or long, then you use these two functions, HTONS and HTONL. From network to host, when it is coming from network going to host, then NTOHS and NTOHL, network to host, short or long. Now, there are different type of sockets, X.25 sockets, Unix sockets. So now, for if you are dealing with internet socket, there are two kind of stream sockets. That is, it may be TCP, it may be UDP. TCP is connection oriented, it relies on TCP to provide reliable two-way connected communication. SOC digigram means it relies on UDP, user datagram protocol. The connection is unreliable, no connection is established. So the first and most important thing, if you understand this, everything you will be understanding. First thing is socket. Socket is a function. This is going to give you a file descriptor. If you know C, if you know C++, fopen gives you a file pointer. So that file pointer, just like that, you understand that this socket function gives you a file descriptor. This is a file descriptor. Inside this you have int domain. This int domain, that is, as I said, different type of sockets it can be. So if you want TCP IP internet base, so here you'll give the domain. For example, pf underscore inet. Type is, it can be UDP, it can be TCP. So sock stream for TCP, sock diagram for UDP. And protocol, you can put it 0, it will choose the best type it wants. Now, this is a file descriptor. Socket will return socket sock fd. So this sock fd is integer type. This is the file descriptor. So socket function will return -1 if there is any error. This is an example, pf inet. This is the domain. Sock stream is type and 0 is the protocol. Now the second thing which comes in this sockets are structures. See, structures have different data types you can put. The basic is for all the sockets, it's struct SOCK Okay. Now this holds socket address information for many types of sockets. So this is the basic one for many types of sockets. So you have SA family, it can be any family, like AF underscore this XXX can be any XXX. So it can be, as I said, different type of sockets can be there. So this is the inet or whichever you use. This is the 14 byte of protocol address. This is 14 byte. So this is the basic one. Now, why we require the other structure then? This is SOC ADDR was already there. Why we need this underscore IN? Why we are creating it? Now these two are almost parallel. So we are creating another structure. This is a parallel structure that makes it easy to reference elements of the SOC address because we have to deal with different elements. So this is exactly same as this. These two are exactly same. So we have just put a underscore IN. So first is the AFINet. We want to use internet, port number, internet. As I said, socket is all about the port number and the IP address along with the type of communication. So these three we want it here. So first, second, third is there, and since this all others are remaining, and we want these to be equal, So that is why we set all the to 0. Now we have other thing also, that is the IP is in other form. Then we have the string and we have the byte stream. So we need to convert this IP. We need to convert binary IP to string or string to binary IP. So we have certain functions for that. inet underscore aton and inet underscore noa. So here if you see, you have two parameters in this function. So this is a, you understood sock addr underscore in now. So we can give these three items here, and then we converted the IP. We need to convert it. IP address, that is, it is a 32 byte, it's decimal dotted, but we need to convert it between the parties. In your program, you need sometimes in string, sometimes in the other form, the binary form. So these are the functions, inet underscore aton and inet underscore noa. I hope you got the idea. So this is going to give you the result. Then we have a bind. What port I am on, that means you are talking about a system. IP is fixed on internet. Then what about the services? Because different application services are running. That is, it may be some UC browser, it may be some Google Chrome or some FTP. So this port binds to actual application, actual service, actual process. So this is used to associate a socket with a port on the local machine. The port number is used by the kernel to match an incoming packet to a process. Packet is coming to which process? To Google Chrome it should go to FTP. That is what is done here. So bind is, the parameters are sockfd. Sockfd now. Sock addr also Now this is the, I'll just tell you, this is the int addrl. So basically this structure, and this is the length of that structure. So my underscore addr is a pointer to struct sock addr which we made, that contains what? That contains main information, IP address and port. Then we have the size of, that is, we are just taking the size of this addr-lan. So as I'm saying, this is a pointer. My addr is pointer. Now you can also put it as 0, sign port as 0. So it will choose an unused port at random. You don't have to specify it. Now if you want to use my IP address. So now you can use this my addr SINADR.SDADDR. This is an example. We have sockfd, we have a structure, as I said, my addr. So we made a structure. Socket we opened, we gave three parameters. Now we entered these three things, that is the protocol, then port and the IP. And we converted it also, inet we used. So as I told you earlier. Now here, now these three things are very important. This we entered. All these remaining we just put it to 0. Now we binding it because we are binding it to a port number. So we have the first as sockfd, we needed file descriptor. Then we have the struct as sock addr, and now we have the reference of my addr, and now the size of this sock addr only, structure only. Now the other thing comes is connecting to a remote host. Please understand, you are now connecting to a remote host. So for that you need connect. Inside this we have sockfd file descriptor. Now this is a server address. Please understand, it's a server address, and again the length of that structure addr-len is the length. So sockfd is the file descriptor written by the socket, and this serv underscore addr, this is a pointer to a structure which is sock addr, that contains information of what? The destination IP and port. Okay, destination IP and port. Then we have this one, destination one. Then you have to connect to the destination, right? So now this is, of course, this is the length. So that is the length of this structure only. If it doesn't work, -1 will be returned. So here we see the example. We have IP and port. We have just hard coded it. Now we have sockfd. So we have the structure also. We put it as destination address. Now we dest addr. Now socket, we opened the socket. Now sockfd has the file descriptor. We entered three things. Now this is INET host byte order. Now D destination port has to HTONS function, as I told you, network byte order. So this is the what we have hard coded, and here we are putting destination IP, which is also hard coded in the address. Other things we put 0. Now we are connecting it. Connect. Now sockfd. Now this is the destination address. We this is a reference to the destination address. Okay, DESTADDR, which we gave in the earlier, and the size. Then they listen. Listen. Now who listens? Server listens for incoming connections. Now incoming connection can be many. So we have listen, we have sockfd, which is the file descriptor, and then backlog. Backlog is the number of the connections can be many. So backlog is the number of connection allowed on the incoming queue. So it can be many. The number of connection that you may allow to be put in queue. So listen returns -1 on error. So this 5 or 6 backlog can have some number. And there's one more thing. First you have to need to call bind before you listen. So we have a socket, then you bind, then listen, then accept. Then accept. Accept does what? It gets the pending connection on the port you are listening to, because there are on the queue backlog, there are certain things which are waiting to be listened. So the acceptance has to be there. So this accept does what? It has sockfd and what? ADDR. ADRDR, I'll just tell you, and then ADDR length. So this sockfd is the socket descriptor. Now information about incoming connection is stored where? Is stored in ADDR, which is a pointer to what? It is pointer to the local structure, which we made IN. You remember? So this accept is whenever we have this ADDR LEN is this just the size. Now it accept returns what? It will create a new file descriptor. Accept will return a new file descriptor, socket file descriptor. Remember it. Let us take an example. So we have these are all things you have to return. You have to, you'll get it everywhere. Now my port and backlog is, now we have again hard coded this port. The port users will be connected to this port, and backlog pending connections queue will be holding. sockfd, new FD. Now this is new FD. So listen, this will listen to sockfd, but new connection will be on new FD. New connection on new FD. So we have two sock ADDR, my address and their address. So we just open the socket, and then we put all the content, AF, INET, my port, and this IP. Put everything 0, other things. Now binding. Now this my ADDR bind. First thing now we have my ADDR and then size of this ADDR. Now listen, you have given sockfd and backlog. In this syn size, what you have given? This size. Now when you put accept, as I said, new FD will be accepting. So sockfd and then their address you have to give, and the size, of course. You remember this is their ADDR. Now the connection has been established, all things are going on. We send and receive. So two functions for communicating over these stream sockets are, or this it can be stream, it can be datagram. UDP is TCP. So send is first option is sockfd. The parameter is sockfd. So this is the socket descriptor you want to send data to. This is returned by socket, or you can get it by accept. Now the message, this is a pointer. You see, it is a pointer to the data you want to send. You're sending it. You want to send. Length is the length of the data in bytes you want to send. And flag is, of course, let it be 0 by now. Now send returns the number of bytes actually send. It may be less than the number you just said in the send. receive. What it does? Now this sockfd is the socket descriptor to read from. It is reading from socket descriptor. It is reading from. So this sockfd is the socket descriptor to read from. Buff is the buffer. The buffers are just like a character array to read the information into. It's a space. Length is the maximum length of the buffer, say 1024 to 56, and flag you put it 0. So recv returns the number of bytes actually read into the buffer. If there is problem, -1. Receive returns 0, the remote side has close connection to you. That means if receive gets a 0, that means remote size has stopped connection. It doesn't want to communicate with you. That's the thing. Now, when you come to DGgram, that is the UDP type. So send to and receive from. Send to receive from, and content are, the parameters are more because there is no connection being established. So we have send to sockfd, all other things you know. Let me tell you what are the special things. So this two, this star 2, this is a pointer to struct as sockDDR, which contains the destination IPN port. And other thing is 2ln is length. In receive from, this from is the pointer to a local struct, which is the socket, that will be filled with IP address and port of the originating machine. Please remember, originating machine. Receive from which originating machine, right? And this from length is again the length. This contains the length of the address stored in from. Finally, the bye-bye, that is the close. So we have close in sockfd. It closes the connection corresponding to the socket descriptor and frees the socket descriptor. So this will prevent any more sends and receive. Closing means closing connection. Now, what diagrammatically we can understand? See, in connection-oriented protocol TCP, we have socket, then we have to open the socket, binding, then listening, then the client will connect, then we accept, then sending and receiving will take place. Then we finally close the ports. When you come to connectionless, only socket and binding is done. There is only socket binding on left and right hand side, server and client. Send, receive from and send to. The two things, listen and accept, is not given here. No listen accept. There is no, because this is connectionless, right? So these are the functions we are going to employ when we actually program. Thank you so much. Take care of yourself.